Hi, this is Pre-Algebra, Topic 3, Lesson 2. Determine unit rates with ratios of fractions. In this lesson, you will find unit rates with ratios of fractions and use them to solve problems. Specifically, you will find unit rates with ratios of fractions, and you will use unit rates to solve multi-step problems. Let's look at solve and discuss it. Allison and her classmates planted bean seeds at the same time as Yuki and her classmates in Tokyo did. Allison is video chatting with Yuki about her class siblings. Assume that both plants will continue to grow at the same rate. Who should expect to have the taller plant at the end of the school year? Okay, so we got Allison's class growing 2.5 inches in 5 days, and Yuki's class growing 5.5 centimeters in 4 days. How do you compare these two rates if they're, different rates within days, right? You have different days. So then this is where you want to find unit rates for both of them. Make the unit rate by converting them into equivalent fractions for 1 day. How fast are they growing in 1 day, right? So for Allison's class, you have 2.5 inches in 5 days. What is this in 1 day? Okay, how many inches? And Yuki's class, 5.5 centimeters in 4 days. What is this in 1 day? How many centimeters do they grow in 1 day, right? In order to have 5 become 1, you're dividing 5, right? So you're dividing 5 for 2.5, and here you're dividing 4 from 5.5. So for Allison's plant, you have 0.5 inches per day. Yuki's class have 1.375 centimeters per day. Which one grows faster? Is 0.5 bigger or 1.375 centimeters bigger? Well, they're also in different conversion rates, right? They're in different dimensions. So is 0.5 inch bigger or 1.375 centimeters bigger? How we can change centimeters to inches or inches to centimeters, right? We know that 1 inch is approximately 2.54 centimeters. So if this is 1 inch, what are we comparing with? You're multiplying 2 for both numbers, and you get 2.75 centimeters. Wait, that's now in 1 inch, right? So 1 inch should be about 2.54 centimeters. So 2.54 centimeters versus 2.75 centimeters, which is greater? Yuki's is greater, 2.75 is greater. So you can say Yuki's plant grows faster. So her class will have the taller plant. Okay. So you need to calculate both rates, both the unit rates, and then you convert Allison's unit rate to centimeters per day. And then you'll compare the numbers, okay? So what must the students do before they can compare the heights of the plants? What did you do? They need to convert unit rates. You can find the unit rates, but if they're not in the same conversion units, then they need to be matching rates, right? So they need to convert units so that each growth rate uses the same units. If this is not done, it doesn't make sense to compare the numbers in the rates, right? You just compare 0.5 and 1.375. Of course, 1.375 is greater, but the dimensions, the rates, the unit rates are different. So it just turns out Yuki's is greater anyway, but you still need to compare them in the same conversion units. All right, so think about why is it useful to write a ratio of fractions as a unit rate? Example 1, find a unit rate involving unit fractions. Sergio is training for a triathlon. His target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his ride? So triathlon involves 3 different types of sports, but right now we're gonna look at biking, his biking skills, okay? He can bike 7 miles in 15 minutes. That is his rate, his speed. So you're gonna use a unit rate to describe Sergio's cycling speed. So change 7 over 15 minutes in a unit rate. We're not usually when we talk about speed, we usually talk about hours instead of minutes. So we're gonna write 15 minutes in terms of hours. What is this in an hour? 15 minutes is 1/4 hour, right? So 7 miles in 1/4 hour. We want to find how much he rides in 1 hour. So in order to get 1 hour, you need to have how many 15 minutes? 1, 2, 3, 4. You need to have 60 minutes in order to get 1 hour. So if you multiply by 4, that is your unit rate. 7 times 28. 7 times 4 is 28. 1/4 times 4 is 1. So then he bikes 28 miles per hour. Okay, so his target speed, which is 25 miles per hour, is reached. He bikes faster than that. All right, let's look at this try question. Sergio increases his target speed to 30 miles per hour. How many more miles does Sergio need to ride in 1/4 hour to achieve this target speed? So 1/4 hour, we just talked about it, that's 15 minutes, right? So in order to get a 1/4 hour, you need to divide an hour by 4. So we're going backwards, right? So divide 30 by 4 and you get 7.5. Sergio must ride 7.5 miles in 1/4 hour to achieve his target speed. So he needs to ride an additional 0.5 mile per 1/4 hour. Okay. How does the unit rate describe Sergio's cycling speed? How? You simply have to see what the unit rates are. Unit rate describes how many miles he rides for 1 hour, right? So that's what you basically need to write down. The unit rate describes how many miles Sergio goes each hour that he bikes. Okay. How is the unit rate helpful in determining how much further Sergio must cycle in a given amount of time each time he increases his target speed. The unit rate would make it easier to find the distance Sergio must bike in any amount of time, not just 15 minutes, but if he wants to have a target distance for 10 minutes, he can calculate that too, right? So the unit rate is very helpful. Unit rate makes it easier to find. Okay, that's the first one. To find the distance Sergio must bike in any amount of time. Okay. Let's look at example 2. Find and apply unit rate involving fractions. Bronwyn mows the lawn every other weekend. She can mow 12,000 feet square in 2/3 hour. The lawn is 36,000 feet square. How long does it take her to mow the entire lawn? So we have a speed, and then we have a target area, right? So first, you're gonna look for relationships. How do the operations used in this table relate to the operations used in the equations at the left? So we can either solve it algebraically in equations, or we can make a table. Okay, so you can cover 12,000 feet square in 2/3 hour, right? A third hour would be 20 minutes, right? 2/3 would be 40 minutes. So in 40 minutes, he would cover 12,000 feet square. The lawn is 36,000 feet square. So how long does he need to mow? You can multiply different numbers to see how much area they would cover. In order to get one, from the fraction, if you want 1 hour, if you want to see how much area he would cover in 1 hour, right? You would multiply 3/2, which is the reciprocal of 2/3. Okay, and then you get an hour. So that means you multiply 1.5 or 3/2 from 12,000 as well. 12,000 times 3/2. You divide 12,000 by 2 and you get 6,000. Multiply by 3, you get 18,000, right? So then you have 18,000 feet square per hour. That's your unit rate. And if you times that by 2, you get 36,000 feet square, and that's what you need. That's your target area. And that gives you 1 hour times 2, which is 2 hours. So you can use the table to find the unit rate and then multiply or divide in order to get to your goal. If you look at the algebra here, we're doing the same thing. We're multiplying 3/2 in order to get the unit rate. And then from here, you're just multiplying 2 in order to get 36,000 feet square. And that gives you 2 hours. So Brownman mows at a rate of 18,000 feet square per hour, and it takes her 2 hours to mow the entire lawn. That is your unit rate. And this is your answer for the entire lawn, 36,000 square feet. Okay, so let's look at the try question. Every other weekend, Browning's brother Daniel mows the lawn. He can mow 15,000 feet square in 3/4 hour. Who mows the lawn in less time? Now we need to compare them. In order to compare them, you need to find the unit rate. unit rates are the easiest to compare. Okay, so you already have a unit rate for running, 18,000 feet square per hour. So how much does the brother Daniel mow in an hour? So let's write a fraction for that, 15,000 feet square in 3/4 hour. In order to get 1 hour, you need to multiply the reciprocal, right? So then you're going to multiply 4/3 to 15,000. So let's multiply 4/3 and 15,000. Divide 15,000 by 3. You get 5,000. And multiply 5,000 by 4. You get 20,000. And so how much area? 20,000 feet square per hour. That is Daniel's unit rate. So you can say Daniel mows 20,000 feet square per hour. And is this faster? He mows faster because he covers more area. 20,000 is bigger than 18,000. Faster than Bronwyn. Okay, Daniel mows more area in less time. All right, let's look at example 3. Solve problems using unit rates. Omar knows that his friend Chris lives 3/5 mile away. Okay. How far is the school from his house? So this is a map. 3/4 inch represents 3/5 miles. Okay. So then looking at this proportion relationship ratio, how can we figure out the actual miles from Omar's house to the school when the map says it's 2 inches? First, you're gonna figure out the unit rate for the distances, right? So first, 3/5 over 3/4. Yes, you may get complex fractions, but you're gonna simplify it, okay? 3/5 over 3/4. You multiply, you divide the number, which means multiply by the reciprocal, 4/3. You do the same thing on the numerator so that you get 1 for your denominator, which is your unit rate, and whatever number you have on the numerator will be how much mile per inches. And that is your unit rate from your inches in your map representing the actual miles. So 1 inch in this map represents 4/5 mile in real life. Okay, so then that is your scale of the map. You're going to multiply both terms of the unit rate by 2 because your map says from house to the school, it's 2 inches away. So 1 inch, if 1 inch is 4/5 miles in real life, if you multiply that by 2, you would get the actual mile of a distance from Omar's house to the school. So multiply both terms of the unit rate by 2, and your equivalent rate would be 1 3/5 mile, and that is the actual distance away from Omar's house to the school. So your final answer, Omar's school is 1 3/5 miles from his house. Let's try this question and see if you can do it by yourself. So Noma bikes 5 miles to Paige's house. On a map, they measured that distance is 5/6 centimeters. The same map shows that the mall is 3.5 centimeters from Paige's house. What is the actual distance between Paige's house and the mall? So this is a different map. Okay, you can draw an imaginary map just to help you visualize it. And she knows that it took 5 miles in real life from Sonoma's house to Paige's house, right? On the map, that's going to be 5/6 centimeters. So you have a proportion, 5 miles per 5/6 centimeters. And the same map shows that the mall, this is a mall, is 3.5 centimeters away from in the map, right? So then what is the actual distance? So that's your rate, your first given information. Change this to a unit rate. And then you convert that to 3.5 centimeters. So first, what do? Multiply your denominator by your reciprocal. So 5 and over 5/6 times 6/5 for both numerator and the denominator. And then you get 1 centimeter on the bottom and 6 miles per centimeter. So that's your unit rate, right? 6 miles per 1 centimeter. So in order to find the equivalent rate for 3.5 centimeters, what do? 1 times 3.5 is 3.5, right? So you multiply 6 times 3.5. What do you get? How many miles? 21. Okay, so it's 21 miles away. The actual distance between Paige's house and the mall is 20 miles. 21 miles. Okay. All right, let's summarize our lesson. In this lesson, we learned how to use unit rates in different situations. So you need to be able to convert ratios and unit rates. Even if you have a complex fractions, you need to know how to get a unit rate out of that by converting the denominator into 1. And then you can use that unit rates to find other equivalent fractions. So that was lesson 2, determine unit rates with ratios of fractions. We'll continue with the next lesson in the next video. Bye.